Slobodan Zelik here today on behalf of Trillium Advisory Group. I welcome you to Beyond 3D, where you'll discover how 4D simulations are driving project cost and schedule reductions. A little bit about myself. I'm a project support specialist with Trillium, supporting construction best practices and technology initiatives on global projects. My background is in project controls, specifically on the EPC side. Welcome again to today's Tech Talk. Really excited to have you all joining me here today. In our small amount of time together, my goal is to shed some light on how 4D programs are driving quantifiable returns on global projects by diving into the following topics. First and foremost, I will address what we like to refer to as the scheduling problem. Then we'll jump right into the building information model philosophy and really the future of BIM, which will serve as a segue into analyzing the BIM dimensions beyond just 3D. Then we'll cover what 4D planning actually is and how it's transforming the construction industry, along with its proven benefits within the project environment. So let's jump right into it. In today's evolving project space, all teams require a schedule for their construction initiatives. The larger the project, the more complex that schedule becomes in order to allow for greater control of operations, even at the lowest of levels. We get that, and it's great, but construction schedules on large and mega projects can easily span hundreds of pages. If you're not a seasoned scheduling professional, it becomes extremely difficult to identify out-of-sequence activities or improvement opportunities by flipping through a 250-page Gantt chart. By following suit with these traditional methods really gives way to missing out on schedule optimization and failing to recognize out-of-sequence work, which can be extremely detrimental to achieving project outcomes. Today's Tech Talk, as we mentioned, will discuss BIM solutions beyond the common three dimensions by combining models with schedule activities to simulate the build plan. Specifically, this presentation will demonstrate how 4D planning is empowering construction teams and project stakeholders with full visibility into the execution strategy and performance outcomes. So let's jump right into the building information model philosophy and analyze what that really is. BIM essentially allows designers to predict the performance of projects more easily before they're even built, respond to changes faster, optimize designs with analyses, simulations, and visualizations, and ultimately deliver higher quality construction documentation. But the scope of BIM really goes beyond just the 3D modeling component that it's known for. It's further defined by dimension subsets built upon the most notable third dimension, being the object model itself, to the fourth dimension, or 4D, which includes time, to 5D, which integrates the cost factor, sixth dimension, or as-built operation, to 7D, which involves sustainability and revolving around that carbon footprint, and even the eighth dimension that incorporates safety factors. Chuck Eastman even expressed in the BIM handbook that there actually exists almost an infinite number of dimensions to the building model, which he defined this capacity as ND modeling or modeling to the nth dimension. Um, let's really take a closer look at, and analyze these BIM dimensions further in the following slides. So the fourth dimension, in short, is the planning process that links the construction activities within the schedule to 3D models, which essentially creates a real-time visual simulation of the construction process over time. Ultimately, this process enables for the assessment and evaluation of the project's workflow and constructability. As this will be the focal point for our presentation today, we'll further analyze 4D and its transformative nature for the construction industry in the following slides hereafter. We'll go over fifth dimension, or 5D BIM, which is the integration of the cost to the model, which allows for the generation of budgets, incorporation of earned value management, and other financial illustrations of the model against time. 5D models help reduce time for quantity takeoffs, increase estimation accuracy, and really allows additional time for cost professionals to spend on value improvement rather than revisions. 6D, or the sixth dimension, extends the BIM for facilities management. As the 3D model includes valuable data of all building elements and services such as engineering, it provides an integrated description of a building. Using this consolidated description with the geometry, relationships, and property capabilities makes it a useful database for asset management. This is where the prescriptive and preventative maintenance process happens. Further, 7D or the seventh dimension is the sustainability component that can be utilized for designers to meet carbon targets for specific project initiatives. And further, 8D incorporates safety aspects in design and construction phases, allowing for overall better safety management. However, it doesn't stop here as far as BIM dimensions go. Beyond this point, it gets user subjective in regard to components added on top of the information model. But as I mentioned, studies have shown that there essentially exist a multitude of dimensions, and more are identified as projects evolve and construction practices adapt. So far we've covered the scheduling problem, which was essentially a matter of complexity in today's evolving project environment. We've dug into a little bit of the BIM philosophy and analyzed the BIM dimensions throughout. Now, what I'd like to cover is what 4D BIM and 4D planning actually is. So let's cover that in the following slides here. So 4D BIM, or construction sequencing as it's often described, provides an additional component of time-related data on top of the 3D model. This additional dimension of schedule information is then associated to specific project components that will be built during the construction phase of the project. In turn, the 4D BIM facilitates a step-by-step visualization of the project as it's progressed throughout each stage or as per the schedule. In simplistic terms, construction activities in the schedule or bars on the Gantt chart are linked to corresponding elements of the 3D model, which includes plant and equipment. This is executed using additional software, but the sequence can then be played back to simulate the planned construction of the project. So how can 4D transform your project? Well, the interdependencies between the schedule and the model within the 4D workflow presents unsurpassed benefits for managing both materials and people on site. Additionally, 4D BIM really allows planners and construction professionals to engage in schedule optimization exercises in order to sequence project tasks in a more logical and efficient manner. This, in conjunction with producing an accurate depiction of the construction in every step of the process, provides invaluable benefits for construction projects. The benefits aren't only realized in terms of budget, but also significantly reduce rework rates and minimize delays. Furthermore, 4D planning really offers stakeholders and team members the ability to effectively visualize, detect, and communicate issues regarding sequencing or even path of construction. Additionally, it's proven to be instrumental in equipment and lay down area planning, just to list a few. It's really clear that 4D, along with the other BIM dimensions, are transforming the manner in which we design, manage, and develop projects in the construction space. In the following slides, we'll elaborate further on the benefits presented by 4D within the project environment. So the benefits of 4D are immediately realized during the scheduling and planning phases of a construction project. The ability to combine scheduling data with the project information model provides stakeholders a detailed simulation of construction progression at the early stages of project development. The digital workflow enabled by 4D BIM allows project teams to identify conflicts well before they happen, prevent downstream clashes, and effectively modify plans in accordance with the newly highlighted data. I mean, as cliche as it sounds, a picture is worth 1,000 words. The ability to look at the constituent parts of a building and test your potential solutions to its construction is of significant benefit and can't really be overstated. It ultimately allows project teams to stay one step ahead of what's being executed on site and to have a clear indication of the following activities thereafter. 4D BIM allows construction professionals to take on a proactive approach to construction planning rather than a reactive one during the execution phase of work. 4D really enables managers to detect issues directly in the planning phase instead of unexpectedly encountering them during the construction execution. Furthermore, one of the biggest advantages of 4D is that the information model quickly conveys and easily communicates the traditional schedule or Gantt to stakeholders and team members. As mentioned previously, sifting through a 150-page Gantt chart on a large construction project can be extremely cumbersome, especially when putting forward required work solutions within tight deadlines. With 4D, the project work areas are easily depicted and construction efforts are communicated in real time or as per the schedule, so that essentially all teams and stakeholders are well informed of current and future progression. Also, the ability to communicate construction team efforts before they are even executed is really emphasized by the visual tool provided by 4D BIM. As schedules can constantly change during a project lifecycle, the associated 4D model will immediately communicate any updates back to the team, and appropriate decisions can be made thereafter. The visualization of project progress provided by 4D really keeps all team members up to date and aligns discipline efforts throughout the life cycle. 4D essentially brings the site to the office and offers a greater understanding of the intentions of various project disciplines. So this essentially gives way to less cross-discipline disputes and minimizes time in meetings, which really serves as an integral benefit to what 4D has to offer. Although the benefits of 4D go beyond just communication and planning aspects of a project, but they're really seen through the simulation capability that it provides. There are really many use cases in which 4D simulations have transformed the planning process of construction projects. 4D, as we mentioned before, brings the site to the office, allowing construction team members to properly visualize all site elements without the requirement of physical presence. This is further enhanced by the ability to properly simulate construction activities and effectively prevent unforeseen conflicts among work efforts. This 4D capability can further be evidenced through the opportunity to efficiently engage in equipment planning and minimizing the downtime of heavy machinery, such as SPMTs, mobile cranes, or excavators. Further simulations, such as heavy lifts, can be utilized through 4D BIM for lift sequencing, such as large vessel installation, for example. Further, 4D simulations allow for increased visibility of the path of construction over the project duration and easily identifies the critical path from a single real-time model. Additional examples of simulation include laydown area planning, materials management, and logistical planning, just to name a few. However, the use cases of 4D simulations are endless, and more are identified as projects evolve and construction practices adapt. So, in summary, it really becomes apparent that 4D BIM can be a game changer in the construction industry. The added benefit of being able to combine the project schedule with a 3D model in order to accurately depict the project's progress in a detailed manner is an extremely powerful tool that helps companies within the space save valuable resources and ultimately increase their bottom line. Teams can leverage 4D programs to collaboratively plan their work, identify out of sequence activities, and improve overall performance. In terms of accountability and engagement, 4D programs engage the entire project team. When the plan is easily understandable, team members understand their role and how to work within the plan to achieve outcomes. In terms of schedule reductions, 4D programs empowers teams to conduct visual schedule reviews, identify out-of-sequence work, perform what-if scenario analysis, and optimize their schedule to achieve improved performance. Essentially, when schedules are optimized and out of sequence work is eliminated, project costs are reduced. 4D programs are driving quantifiable cost reductions on projects across all industry sectors. And further, good planning is a primary foundation for safe work execution. 4D programs enable project teams to effectively plan their work before stepping foot on site, identifying and mitigating risks before they cause harm. All in all, 4D programs are driving quantifiable returns on all global projects. The evidence is out there, and the multitude of companies have already begun adopting this planning process. I thank you all for attending today's webinar, and I hope you were able to take away at least something regarding the future of BIM, and specifically the 4D planning and how it can transform the way we design, manage, and develop projects today. I'll now open up the floor to any questions you may have. If we don't get to all the questions today, I'll be sure to reach out and provide clarification through direct message or email. Thank you again.